Hi students, in this video we will discuss about absolute convergence. Absolute convergence. Absolute convergent. Okay, so first I will explain about this concept. After that I will give you definition of this absolute convergence. Okay, so for this let us consider summation a n b a any series. That means here summation a n b a given any series. Okay, that means here summation a n is either positive term series or negative term series or positive and negative term series. Okay, so first let us consider summation a n b a any series. That means here summation a n may be either positive term series or may be negative term series or may be positive and negative term series. Okay, so here summation a n is a given series. Okay. Also we consider the series whose terms are the absolute values of the terms of the given series. So also we consider the series whose terms are the absolute values of the terms of the given series. That means summation modulus of a n. So here summation modulus of a n is nothing but absolute value of the terms of the given series. So here summation modulus of a n is nothing but absolute values of the terms of the given series. Okay, so here summation a n is the given series and summation modulus of a n is the new series. Okay, so here what is summation of modulus of a n? Absolute value of the terms of the given series. Okay, here if the series of absolute values that means summation modulus of a n. If the series of absolute values that means summation modulus of a n converges, then the series that is summation a n is called as absolutely convergent or converges absolutely. Here listen, if the series of absolute values is nothing but summation modulus of a n converges, then only we can say that the given series that is summation a n is called absolute convergent or converges absolutely. Okay, that means if the new series of all positive terms also convergent, then virginal series will convergent. So finally absolutely convergent is nothing but a series will convergent even when you have to take the absolute values of each term. Absolute convergence is nothing but a series will convergent even when you have to take all the absolute values of the each term. Okay, so simply we can say that summation a n b a any series. Okay, if summation modulus of a n is convergent, then we can say that the series summation an is absolute convergent. Okay, listen, I will explain once again. Listen, suppose summation a and b a given series. Okay, if summation modulus of an is convergent, then we can say that the given series, that is summation an, is called as, we can say that the given series, that is summation an, is absolute convergent. Okay, first of all, summation a and b a given series. Okay, if summation modulus of an is convergent, so then we can say that the given series, that is summation an, is absolute convergent. Okay, okay, now not absolutely convergent means, suppose a and b a given series. If summation modulus of an is divergent, then we can say that the given series, that is summation an, is not absolute convergent. Okay, okay, are you understand? Okay, so once again I will explain. Suppose summation a and b a given series. Okay, if summation modulus of an is convergent, so then we can say that the series, that is summation an, is absolute convergent. Okay, suppose summation modulus of an is divergent, so then we can say that the series, that is summation an, is not absolutely convergent. Okay, so now I will give you definition of this concept. Okay, write down definition. A series summation an series converges absolutely if the series of absolute values, that is summation modulus of an, is convergence. Okay, that means a series summation an is converges absolutely or absolutely convergent if the corresponding series of absolute values, that is summation modulus of an, is converges. Okay, so this is the definition of absolute convergent. Absolute convergent is nothing but summation of modulus of an is convergent when summation an is a given series. So the series, that is summation an, is called as absolutely convergent. Okay, write down note. Okay, if summation an is a series of positive terms, then summation an is equal to summation of modulus of an. Okay, if summation an is a series of positive terms, so then summation an will be equal to summation of modulus of an. Okay, clear? Because an is here positive term series. Okay, that means, so from this we can say that if the terms of the series an are positive, okay, if the terms of the series an are positive, so then absolute convergent is same as convergent. Okay, that means for such a series, that means positive term series, there is no difference between convergent and absolute convergent. Okay, so here if the terms of the series an are positive, so then absolute convergent is same as the convergent. Okay, that means there is no difference between convergent and absolute convergent. Okay, if summation an is a series of positive terms, then summation an always summation of modulus of an. Okay, because summation of modulus of an is nothing but summation of an. Already we know that. Okay, modulus of any number always positive. Now let us see one example. Okay, write down problem. Show that ST means show that the series summation n is equal to 1 to infinity minus 1 whole power n plus 2 by n square is absolutely convergent. Okay, show that the series is absolutely convergent. Okay, listen. So first let us consider the given series as summation an. Okay, summation n is equal to 1 to infinity minus 1 whole power n plus 2 by n square. Okay, therefore an will be equal to minus 1 whole power n plus 2 by n square. Okay, okay. Now to show that the given series is absolutely convergent. Okay, so first we have to find modulus of an. Okay, tell me modulus of an. So here modulus of an will be equal to modulus of minus 1 whole power n plus 2 by n square. So now which is equal, okay, modulus of a by b is nothing but modulus of a by modulus of b. Okay, write down. So modulus of minus 1 whole power n plus 2 by n square is nothing but modulus of minus 1 whole power n plus 2 by modulus of n square. So now which is equal to, so here modulus of minus 1 whole power n plus 2 always 1 divided by modulus of n square always n square, because n square is always positive. Okay, for all n belongs to n. Okay, so here student, remember that point. So what is the point? Minus 1 modulus of minus 1 whole power something is there. Suppose something is there. Modulus of minus 1 whole power something is there. Okay, modulus of minus 1 whole power something is there. Okay, it must be equal to 1. So remember that point. Okay, so modulus of minus 1 whole power something is always 1. Okay, remember that point. For example, minus 1 modulus of minus 1 whole power n always 1. Similarly, modulus of minus 1 whole power n square plus 2 is always 1, as you are like. Okay, so here modulus of an is nothing but 1 by n square. Okay, next we have to find summation modulus of an. Okay, so here summation of modulus of an is nothing but summation modulus of n is nothing but 1 by n square, summation 1 by n square, which is convergent by P series test, because P is equal to 2 which is greater than 1. Therefore summation modulus of an is convergent. Already we know that if summation modulus of an is convergent, then the series, that is summation an, is called absolute convergent. Therefore summation an is absolute convergent. Okay, Okay, if summation modulus of an is convergent, then summation an is called absolutely convergent. Okay, so that is the concept. Okay, so next we will see second example. Okay, show that summation n is equal to 1 to infinity minus 1 whole power n by n is not absolutely or absolute convergent. Show that the series, that is summation n is equal to 1 to infinity minus 1 whole power n by n is not absolute convergent. Same, we have to follow same procedure. Okay, don't worry. So first let us consider the given series as summation an. Therefore an will be equal to minus 1 whole power n by n. Tell me modulus of an. Modulus of an is nothing but modulus of minus 1 whole power n by n. Okay, so now modulus of minus 1 whole power n by n can be written as modulus of minus 1 whole power n by modulus of n. Okay, modulus of minus 1 whole power n always 1 by mod of n always n. Okay, because n is natural number. Okay, therefore summation modulus of an will be equal to summation 1 by n, which is divergent by P series test, because P is equal to 1. Therefore summation modulus of an is divergent. Summation modulus of an is divergent. Already we know that summation of modulus of n is divergent, then the given series is not absolutely convergent. Therefore summation an is not absolute convergent. Okay, or absolutely convergent. Write down third problem. Show that summation n is equal to 1 to infinity minus 1 whole power n 2 power n by n factorial is absolutely convergent. Okay, show that the series is absolutely convergent. Okay, we have to follow same procedure, no problem. So first let us consider the given series as summation an. Therefore an will be equal to minus 1 whole power n 2 power n by n factorial. After that we have to find modulus of an. Modulus of a is nothing but modulus of minus 1 whole power n 2 power n by n factorial. So here modulus of minus 1 whole power n is nothing but 1, modulus of 2 power n is nothing but 2 power n by modulus of n factorial is nothing but n factorial. Therefore summation modulus of an will be equal to summation of 2 power n by n factorial. Okay. So now we want to show that the given series is absolutely convergent. Okay. So here we have summation modulus of an is summation 2 power n by n factorial. Okay. So here to show that the given series is absolutely convergent, okay, just we have to show that summation modulus of an is convergent. Okay, to show that the given series is absolutely convergent, just we have to show that summation modulus of an is convergent. That's all. How to show that summation of modulus of an is convergent? Okay. So here to show that this series is convergent, so here I am using ratio test. Ratio test. Okay. For using ratio test, so first we have to find modulus of an plus 1. Modulus of an plus 1. Tell me modulus of n plus 1. Already we know that modulus of an. Okay. modulus of an is nothing but 2 power n by n factorial. Therefore, modulus of an plus 1 is nothing but 2 power n plus 1 by n plus 1 factorial. Already we know that modulus of an. Okay, modulus of an is nothing but 2 power n by n factorial. Therefore, modulus of n plus 1 will be equal to 2 power n plus 1 by n factorial. So here 2 power n plus 1 by n plus 1 factorial can be written as 2 power n into 2 by n plus 1 factorial can be written as n plus 1 into n factorial. Okay, already we know that ratio test. So next we have to find limit L value. L is equal to limit n tends to infinity. Here modulus of an plus 1 by modulus of an. So now which is equal to limit n tends to infinity, modulus of n plus 1 is nothing but 2 power n into 2 by n plus 1 into n factorial by modulus of n is nothing but into n factorial by 2 power n. Now which is equal to limit n tends to infinity, 2 power n get cancelled, n factorial get cancelled. So finally we get 2 by n plus 1. So next we have to apply n tends to infinity. So here we get 2 by infinity plus 1. So now which is equal 2 by infinity plus 1 is nothing but infinity. 2 by infinity is nothing but 0, which is less than 1. By ratio test we have the series, that is summation of modulus of an is convergent. Okay, therefore by ratio test we have summation modulus of an is convergent because we can see that here L is equal to 0, which is less than 1. Therefore summation modulus of an is convergent. Therefore summation an is absolute convergent. Write down, students, very important theorem without proof. Okay, if summation n is equal to 1 to infinity modulus of an convergent, then summation n is equal to 1 to infinity an convergent. Okay, if summation modulus of an convergent, then summation an convergent, but the converse need not be true. Okay, if summation modulus of an convergent, then summation an convergent, but converse need not be true. Okay, which means that an absolutely convergent series is always convergent series. An absolutely convergent series is always convergent, but the converse need not be true. Okay, so from this theorem we can say that absolutely convergent series is convergent. Absolutely convergent series is always convergent, but here the converse of this statement is false. That means many convergent series do not convergent absolutely. So here the converse of this theorem, the converse of this statement is false. That means many convergent series do not converges absolutely. Okay, once again I will explain about this theorem. Okay, every absolutely convergent series is convergent series. Is the converse of this theorem true? That means every convergent series is absolutely convergent? No. That means every convergent series need not be absolutely convergent. Okay. That means write down. That means every convergent series need not be absolutely convergent. Okay. Remember that point, students. Every absolutely convergent series is convergent series, but every convergent series need not be absolutely convergent. Now let us see one example. Okay. Example. Okay. So here I am taking a series, that is summation n is equal to 1 to infinity minus 1 whole power n by n. Let us consider summation an, which is equal to summation minus 1 whole power n by n be a series. Okay. Then we have an minus 1 whole power n by n. Okay. So now this series can be written as, that means an can be written as minus 1 whole power n into bn, where, tell me what is bn? 1 by n. Okay. If you observe that here bn always greater than 0 for all n belongs to n, because numerator is positive, denominator is also positive, positive by positive always positive. Next, second condition, limit n tends to infinity bn is equal to limit n tends to, bn is nothing but 1 by n. So next we have to apply n tends to infinity. So here we get 1 by infinity is equal to 0. Next, third condition, bn always greater than bn plus 1 for all n belongs to n. Okay, so by alternating series test, by alternating series test, we have summation an is convergent, because so here first condition, second condition, third condition are satisfied. Okay, by alternating series test, we have summation an is convergent. Okay. Now tell me, summation modulus of an is nothing but summation of modulus of minus 1 whole power n by n is nothing but summation 1 by n, because minus 1 whole power n, modulus of minus 1 whole power n always 1. Okay. So here summation 1 by n, which is divergent by p series test. Okay. Therefore summation modulus of an is divergent. Therefore summation an is not absolute convergent. Summation an is not absolute convergent. So here summation an is convergent. Okay. Summation an is convergent by alternating series test. But summation an is not absolute convergent. That means every convergent series may or may not be absolute convergent. That means the converse of this theorem is not true. That means every convergent series need not be absolutely convergent. Okay, so this is the example for converse of this theorem. Okay, so finally I will explain. Okay, so remember that point. Every absolute convergent series is convergent series, but every convergent series need not be absolute convergent. So that is the point. Okay, remember that point. Okay, students, I will give you some problems, okay, regarding this topic. Okay, please do it. Very simple problems. First one, ST means show that summation n is equal to 1 to infinity sin n by n square is absolute convergent. Show that the series is absolute convergent. Second one, show that summation n is equal to 1 to infinity minus 1 whole power n by 2 power n is also absolute convergent. Okay. Third one, show that summation n is equal to 1 to infinity, okay, minus 1 whole power n by n factorial is also absolute convergent. Okay. Next, fourth one, show that summation n is equal to 1 to infinity minus 1 whole power n 2 power n by n square is not absolute convergent. Not absolute convergent means, okay, summation modulus of an is divergent. Okay. Okay. Fifth one, summation n is equal to 1 to infinity, okay, cos n pi by root n is not absolute convergent. Okay, show that summation n is equal to 1 to infinity cos n pi by root n is not absolute convergent. Okay, please do it these problems. Okay, very simple.